Here we are again on the screen. Welcome aboard. It's the SBAU Astro Hour. It's number 283 in programs, and you're invited to stay with us for the hour. Join us as we on the screen take on the cosmos. Try to understand it, explain it, and all for the Santa Barbara Astronomical Unit, SBAU, which is based in our beautiful Santa Barbara Museum of Natural History. Once again, proudly, I'll be your host, Ronnie Herron, ready to introduce my good friends on the screen from the club around me in a moment. SBAU, is going to be there available just about anywhere we'll go. Set up our scopes with a dark and unlit sky, day or night, actually. For example, recently we dazzled the campers at Refugio State Park at night and they saw Jupiter and the moons and everything else. And don't just give us a call.
Jupiter's in the morning sky.
Jupiter's in conjunction.
Well, then they all went back to their campsites terribly disappointed, gentlemen.
Good recovery.
Good recovery, Ronnie.
We'll get an update from our outreach guy to the right of me on my screen here. We have an interesting a heavy weekend in 2 weeks. 2 Fridays from now is Jerry's speech at our big meeting called The Search for Habitable Planets, which I can't pronounce. And the next night will be our second Saturday Star Party. Here are the hot topics for the week on the Astro Hour. How does a near-Earth asteroid get reclassified as a faint but active comet? Well, a case of mistaken cosmic identity. What exactly are the stars we call the Sisters of the Moving Group? Well, it's a giant ladle, and it's in Ursa Major. We're going to have more on our president's opening speech, August 7th, namely planet size and the atmosphere involved this hour. Ever heard of STEM? STEEHM? We'll tell you. And there's a magnitude 9 asteroid, 3 Juno, out there flirting with the moon just after dark. We got photos. Who made up the constellations we see anyway? What happened to the super one called Argo Navis? And the status of the planets? Well, Jupiter, I just heard, is about to reach conjunction with the sun, and it's a morning planet. Let's meet the crew, shall we, ladies and gentlemen? Veteran of various research and development spots out on Hollister, and a possessor of a doctorate, but we don't call him doctor, our president, Jerry Wilson.
Good morning, everybody. Good morning, Joyce, and my grandsons, Riley and Calvin.
And how's the first lady, Pat? How is she doing?
She's doing very well.
Oh, we're so glad to hear it. Well, we have a super, let's see, what would you call it? To have Scope Will Travel. That's our club's outreach guy, Chuck McPartland.
Oh, good morning.
Comes with a pet rock that has an incredible history. You won't believe it. He's also married to a Pat, who is our merchandise manager. That job's slowly going away, but she's probably one of the best treasurers we've ever had. Retired Westmont science professor and longtime editor of our newsletter is Tom Whittemore.
Morning.
Bakes bread and watches birds. Sometimes bakes a bird in his bread, and I won't eat it, but he's married to Maureen.
Just 420 blackbirds.
You do a good job on the newsletter. We're looking forward to getting it right about the turn of the month. Tim Crawford's with us, grand lens guy, lens expert, photographer of the sun.
That's his image, Ron. That's his image behind his head. That's the one.
Yeah, that's it right there.
Isn't that pretty? Look at that.
Do I see one sunspot on it about the middle?
There's a big filament. That's a little.
I don't see my big.
Look at that
prominence in here, but that's pretty good.
Yeah, there's one about 7 o'clock.
Yeah.
Oh, can you see that? I can't see it on mine.
Oh, it's just beautiful, Tim.
Yeah,
that's
not bad for just winging it.
That was two Sundays ago. I think Tim shot that.
There you go, Ronnie. You wanted to see what we do. There it is.
Yeah. Well, is what you guys do when you watch the sun through the Palmer scope. Is that only on Sundays?
No.
No.
Every day the tourists line up at the museum and look right at our sun through a filter, of course.
Right. Mike Jacoby is running Monday, Tuesday right now, and I think David shows up on either one of those days to just to assist him.
I think David shows up a lot. I think he's on
He
Mondays.
does. He was there yesterday too. Yeah.
Yeah.
Well, if you can throw it behind you every week, I don't think that Jerry would mind. Here's a flash of what our sunlight looked like yesterday. If there's
Well,
something to see other than a round yellow ball, the prominences, I don't know.
The sun's quite active right now.
Yes.
we
yes.
had the clouds kind of cleared yesterday
Yes.
in our viewing time, and we had some really nice prominences.
Mhm.
Well, is it on the high end or low end of the changeover of its 22-year cycle? Do you know?
We're
It's
just
getting
about
lower.
yeah, it's just at the past the peak.
Yeah.
It almost makes the sun a variable, doesn't it?
No,
Not at all. That's not variability.
No, it's like where the active sun, it gets more and more active, a lot more sunspots, and then they decline for the second 11 years.
Okay,
And
but
I
that's
think there's
not
another cycle like 44 years.
It's a 22-year cycle, but it looks like 11 to us.
Yeah.
peaks and then okay, but it's not like Cepheid stars, which do all kinds of different
No,
band and signs. All right. Hey, listen, everybody, we start our show. This is for July 27th through August 2nd, 2026. And the silly science cartoons that are forwarded to our inboxes by President Jerry, numbered 7. Boy, we got some good ones this week. We like to start the show with this. You want to read this to us, Jerry? What are we talking about here?
Oh, this is, I've been to a lot of places, but I've never been in cahoots. Apparently, you can't go alone. You have to be in cahoots with someone. I've also never been incognito either. I hear no one recognizes you there. I have, however, been insane. They don't have an airport. You have to be driven there. I have made several trips.
Well, have you ever been inebriated?
Inebriated.
Get drunk a lot. They got a drunk
I
tank.
don't remember.
I don't remember.
One of your cartoons, there it is. I think that's the
Oh,
one.
this is a good play on words.
Yeah.
Yes, this is the one I want Tom to do because he's our resident punster. Tom
Oh,
Whittemore,
Sure.
couple of cops.
So be on the lookout. Female, 5'1", brown hair, red dress, wanted for defrauding people as a psychic.
Oh my God.
And it says, "It's about to get real, rookie. We've got a small, medium, at large."
I heard a variation of that.
Very clever.
Yeah,
That's
it really is. I heard a variation of that involving dwarfs at one time. But okay, do you want to explain this? Anybody? Tom, Chuck, you know what this
Sure.
is all about?
Just fine.
Sure. I'm surprised it's showing the whole license plate because usually that's a no-no, but maybe
Yeah.
the person who owns the car did this. But it's a New York license plate and it's Cutie Pie.
Oh, that I didn't get it. I didn't even get it at all.
I just saw the pie, Chuck.
Yeah.
Well,
God, I didn't. I was gonna say, please explain this. I don't get it. Cutie pie. I'll be damned. That's really
first-
good.
Okay, talking dinosaurs in the past. You think you can interpret this, Tim?
Yeah.
I'll give it a whirl.
What are they saying?
He says, "Hey, everybody, look out! It's one of those, the fire and stuff. Despite its names, the thesaurus was quite often at a loss for words."
That's good.
Okay, that was
You can usually tell in old drawings, you can tell a thesaurus by its pronounced gazetteer.
I've often wondered about that. All right, Jerry, we're on the moon, obviously. What's going on?
I don't get this one, actually. I put it in there, hope someone would.
Yeah, I kind of got it.
Futurism, I know that they're at the moon, they're about to plant a flag, and they say, "Oh, Vatican City beat us too."
Right. So those are the keys of the Vatican right there
Yeah.
on that front flag.
But the flag's kind of blank. So if it was like American flag, I would say, okay, that's pretty
Yeah.
funny. But it's kind of blank.
Maybe
Yeah.
it's a Musk flag.
A mess.
In
Okay,
Rome
we'll
or Italy
quietly
or
pass
Rome?
that one on by.
Vatican City. All
Oh,
right.
I remember these cartoons.
All right,
And
go ahead and explain it then, Tim Crawford.
Well, this is all about opera. And when someone asks me if I've ever been to the opera, well, if you count Elmer Fudd singing "Kill the Rabbit," now I think that was to Wagner's. It's a
Lohengrin.
Wagner tune, right?
Right,
Wagner.
right.
Yeah.
And
Looney Tunes.
the Ride of the Valkyrie.
Yes.
Twilight of the Gods.
Yeah.
Yeah, and then I said, yeah, then yes, I've been to the opera. But
Yeah,
I
it is the
remember
Valkyrie
the
one.
cartoon well. It was really, I've never seen Elmer Fudd that mean.
Yeah, Disney introduced me to classical music with this one and The Barber of Seville. And then, of course, their Fantasia movie.
Yeah, yeah, yeah.
Well, Disney didn't do Elmer Fudd. This was Warner Brothers.
Yeah.
They were funnier. That was Meep Meep, Roadrunner, Wiley. You know, those are the
Roadrunner
funny.
was a later invention, simpler plots.
Yeah, it's true.
But it foretold Amazon.
Yeah, yeah.
Okay, Chuck, what's going on here? An ancient battle about to begin.
Okay, you got a bunch of medieval forces standing there getting their pep talk outside the walls of a castle they're going to attack. And the leader says, "Remember, men, history is written by the victors." And one of
Somebody's
them makes a
thinking.
face and says, "Oh, great, there's a writing assignment too."
But it's true. Might to be right or no, right? Might is right. Is that what Hitler said? You win, you get to write the history books. Okay, we got a busy hour ahead of us, gentlemen. Mr. Professor Wilson, looking forward to your talk.
Now, this
Oh my
was too
God.
good to pass up. This hits right on the boundary line, which we sometimes fall into about, is it a comet or is it an asteroid?
Yeah.
This is a definitive asteroid that turned out to be actually an active comet. But it was so inactive that it took special observations to realize it had any kind of tail at all.
Really?
And therefore it changed its designation from 1998 SH2 to P 1998 SH2. The P was added because it was a periodic comet. Before it was just an asteroid.
Yeah. Yeah. And if you look off to the left, Jerry,
Yeah.
you see the Pleiades.
Yeah.
And down below on the left, you see the Hyades with Aldebaran. Yeah. It's really neat. Of course, the bull.
Now this is an artist's rendition. This is not a
Yeah.
photograph.
But they used, real stars.
Yeah.
This one kind of scared me.
Why?
When Jerry goes further with the images, it really scared me because it's quite a big comet.
Oh, that's right. I had one where it's on the town in New York.
Oh yeah.
Yeah, you're right.
And and when you think that it's dark, that really got to me. I was just
Well,
thinking,
it's not dark if the light shines on it.
Yeah. And
It's
and,
dark.
and a lot of asteroids are that they have low albedos.
Yeah. Yeah.
Does
So
it have a
this is
name?
what's that?
Did it have a name either before as an asteroid or now as a comet? Does it
That's
have a
its name right there.
Yeah.
The phone number.
1998
Okay.
SH2.
I'm going to call that and see what I get.
So this is its orbit, and this is the Earth right here. And right now, this is where it is. So it's at a close position to Earth. And that allowed scrutiny of it with big telescopes, and they spotted its tail. Very thin tail. But it's I forget the name of this kind of asteroid, but this is Mars, and this is the asteroid belt out here between Mars and Jupiter. So this one is in that belt, but it's above the belt here. You can see where these little lines, that's where it intersects the ecliptic. So this is above the ecliptic here, so it's tilted. And here it's below the ecliptic.
Yeah, but
So
isn't that Earth?
this is Earth here.
Mhm.
Oh,
It's got Earth right on the name Earth, right on the comet.
Gotcha.
But here, this is the thing.
Yeah, I
Oh,
misconstrued that.
this is an interactive website. It's very interesting. You can change the date. You can have it watch the orbits evolve slow or fast. And this is where I think that,
That's where it is now, probably,
yeah, that's where it is at this
on
time.
the date you picked.
And
Yeah.
I put in yesterday's date. And there's where Earth is today. So it's not close to Earth now, but you can go around and it will eventually come close, about this close to Earth. But it
And
goes,
they were seeing anomalies in its orbit, and that's what made them really take a closer look at it, because it was outgassing and that was moving it, acting like little rockets.
right. Chuck just let the cat out of the bag here.
It's okay. That's part of what scared me.
The key point, no, they were looking at it. They track the Earth's, what is it, defense system, planetary defense, checks on all the near Earth orbit. And this is a near Earth asteroid, near Earth object. And it wasn't there. We checked and it wasn't there. It was in some
Interesting.
other orbit. So they figured out what was going on, how much motion it needed to get to do that and to be off. And then they checked it and they found that it was operating little attitude control jets on its own that nature provided.
Maybe they should have turned the lights off. They might have seen it on the list.
Yeah.
But we don't have two astronomers' name on it, do we? Two
No,
guys-
no. Asteroids seldom these days there are just way too many of them. They seldom
Well-
get named.
Well,
One-
is the definition of an asteroid, it doesn't have the gases and frozen liquids that would become a tail? It's just all rock?
No.
I think we talked about this. And
Yeah,
we
apologize.
talked about
it's
this
all
many
fuzzy.
Our previous talks on this is why I included this. I knew it would get a rise. This is where the thing is now. It's from
And
that same website.
The problem right now, Jerry, is the sun's in Cancer.
Yeah.
Yes, yes, it doesn't guarantee a nighttime view.
Yeah.
Now, this doesn't, you don't see it very much here, but this is faded from here because that's the way the website indicates that it fades during the daytime.
Okay.
So this is a daytime sky, as just was pointed out here.
But the slightly curved line right below it is its path?
This here,
That's the ecliptic.
Yeah.
Oh, that's the
remember
eclipse.
Oh, it's slightly above the ecliptic right now.
Yeah.
And that's that distance.
So Ron, sometimes on Sundays, I'm in the Palmer Observatory. I bring up the targeting software, which shows where the sun is. Okay, because we point the telescope at the sun, and the sun is right in the middle of Cancer right now. People really like that, to know where the sun is and what zodiacal sign. Okay.
But you're not tempted, are you, Tom, to bring up the dreaded astrology and start asking it?
Well, I just say,
here?
I just say to people, if you were born today, okay, you would really be, on this date, you would really be a Cancer,
That's right.
Cancer crab.
And you'd be a moody person who likes to sleep in and argue and.
But see, right now, people would say, astrologers would say, you're a Leo. That's just not right.
No, they're actually what Tom is getting to is there are two types of astrology. And you can have as many types as you want. It's basically a myth. So one's tropical astrology, one is sidereal astrology. Tropical astrology is assuming the stars have not moved from 2,000 years ago.
Yeah.
Sidereal astrology is correcting for the motion of the creep of the zodiac around it, so that's the difference between you being a Cancer or a Leo right now.
Jerry, what was the second name? One was the one that where it
One
assumes.
is tropical astrology and the other is sidereal astrology.
Oh, sidereal. Okay, yeah, interesting.
Now, and then of course, no one has accounted for the fact that there are 13 signs in the zodiac
Right.
well anymore. So
But
if
has
you were born in Sagittarius, you were probably actually an Ophiuchus.
Well, has mankind been doing that stupid, I'm a Leo, what are you, forever? Or is that only recently in the last 100 years?
For the last 6,000 years.
Yeah.
Really? People would say I'm a Taurus?
That's
I'm
a pickup
Capricorn.
line in some comedy movies that I've seen, romantic comedies.
Yeah. Yeah. Chuck was born under Ophiuchus.
Yeah.
Yeah.
Figures.
And it was probably only rich people that had their actual astrological analysis done.
Oh, is that right?
There is an interesting book written by a professor of astronomy at Tulane or somewhat one of the Eastern colleges. And he points out, he does a history on astrology and points out that in Israel, around the time of Jesus, there was it was forbidden to do astrology charts.
Really?
So these three wise men came from the east and they said, we're following the star. And Herod said, what star? And they said what they were talking about was a star, a conjunction of things on their astrology charts. But people in Israel didn't do astrology charts. So that's why no one could see it, because it wasn't a star in the sky. It was a conjunction of things. So based on that hypothesis, he calculated Jesus' birth date as something like, I think it was April 4th in the year 4 BC. It's an interesting book. If you're interested, I can loan it to you.
Well, I even heard a story. There was a starburst or a supernova that.
Nope.
Yeah, there's no astronomical event in the sky.
Well, there was a conjunction that he's talking about was like with Jupiter and Venus, or two
Yes.
bright planets in Leo, and Leo was associated with Israel at the time.
Yeah. And the two planets that were conjuncted were signs of a leader or a strong leader.
Yeah.
So, but anyway, that's for a later chapter, maybe.
It's myth reinforcing myth.
Yeah. Now, this is an image of the dark comet, as I called it in my talking points. I'm not convinced this is a real photograph of that comet or an artist rendition. It's common, if you go to different websites about this comet, you see this picture, but I can't find any accreditation for it. So take it with a grain of salt.
It looks a lot like the one that they smashed the refrigerator into.
Oh,
Deep Impact.
yeah.
It looks like it's only been hit by rocks, not very often.
Well, it's got a
Well,
lot of impacts.
Yeah.
And
Now, this does show.
Ron, I just point out something to Ron. You can see in this photograph. Well, the other one, Jerry, the one you just had.
Oh,
Over the city.
That one. That you can see that particular body participated in the musical On the Town.
yeah. On the town. I gotta filter these things more for potential puns here.
That's really neat.
Anyway, this is the Tim. This is your fearsome one.
That one got me.
Yeah.
Yeah, and you can tell it's just a fake image because the light from the torch of the Statue of Liberty is on the dark side of the comet.
Dark side.
Wow.
Okay, anyway,
Mhm.
now we move on to a much more interesting topic, and that is moving groups. So this is currently, this is tonight at 9 p.m. If you look up in the north, you will see Ursa Minor and Ursa Major over here. Ursa Major is harder to spot in this because they have all these spider webs hanging off of it. But the asterism we're looking at is this thing here. And it turns out that people spotted back in the 1800s, people spotted that all of these stars except one, I believe.
Two.
Two? Okay.
Yeah, 5 out of the 7.
Okay, 5 out of the 7. This is a drawing from the 1800s showing the Ursa Major motion of the stars. And these little arrows give the way that it moves there. So this one, this one, this one, this one, and this one are all moving together. A key sign that they either are in or came from a cluster, an open cluster. These two here, Alpha and Nu, or Eta, are going this way. So they're not part of that group. So it has become called at that time the Ursa Major traveling group or motion group.
Oh.
Go ahead.
Made of the same the same nebula stuff, right?
The what?
Made out of the same dust and gas, do you think? Is that how?
That's a
Yeah.
long time before this picture was taken. These stars were are sisters from the same nursery. They formed out of the cloud. They formed, and then for a while when they started fusing, their solar wind from each of these stars blew all the remaining dust away. So the star formation stopped. And then you have an open cluster. That's how open clusters are formed. But they still have the similar motion that cloud has. And as they travel around the center of the galaxy, they're each in a slightly different orbit. So they start drifting apart from each other and they break up. This is not in a cluster anymore, but it has not broken up enough that you can't identify by its motion which stars were from that same nursery.
Really?
And Jerry, I took that in a planetarium program. I wanted to see how the Big Dipper would change over periods of time.
Yeah.
And man, I moved it forward like about 500,000 years. It changed, but not much.
No, those two stars that don't move together, those are the ones that do the big change.
Yeah. But I was amazed at how long a period
Yeah.
and how little change there was.
Just to clarify, gentlemen, the handle is the tail of the bear, isn't it?
Yes.
Mhm.
It's not a constellation itself, the Dipper. It's
It's
just
an
an
asterism.
asterism.
Yep.
Okay, got it.
It's a recognizable pattern.
Right.
These are, this is a map in our galaxy of moving groups. Ursa Major moving group map up here. So the Ursa Major moving group is located here with the sun here. These other clumps of things and individual stars are noted too. These are associations or groups or streams. We covered that in a previous months and months ago about streams, particularly streams that are formed by globular clusters. And as you remember, globular clusters are these tight balls of stars, and they rotate in a big sphere around the galaxy. They're not in the plane of the galaxy, but as they go around, they sometimes shed stars as they age. And that makes a stream of stars that are moving along the same orbit as the globular cluster is. This, however, is dealing with open clusters, and it's the whole thing is coming apart. So this is the Ursa Major moving group.
Does
Now,
Polaris go in that direction too?
No.
what's that?
Polaris is not part of that. The North Star.
Oh, no, Polaris is not part of this.
Okay.
So a more extensive search has been done for stars that are in that group, and there are, I believe, 57 or 51 stars that have been associated with that moving group. This is from Astronomy Magazine. And these
One
are
of your favorites is in there, Tim.
which one's that?
Gamma Leporis.
Oh, yeah. Yeah.
It's on the previous page,
Oh,
Oh,
right at the bottom.
that
There it is.
yeah, that's the one
good.
I finally think I found it. It got
So
me in real trouble in a chat group.
So they went through pictures of images of the whole sky, because some of these things are not in Ursa Major. They're in other things scattered quite a bit around the sky. So it's become a big group. A lot of the stars have managed to travel far from their core. And so they looked at all the stars that they had data for via computer, and they categorized them as, yes, they're in the moving group, or yeah, they're kind of in the moving group. That's yes, yes, question mark. And then they had some that are just simply a question mark, can't tell. And then there were definite no's. So all the yeses and yes question marks are listed in this chart put together by Astronomy Magazine.
And I've previously seen lists that included stars like Sirius and Procyon.
Yeah.
which
Well,
this group
do you,
doesn't.
do you suppose in a billion years we'll still have
Well,
the
this
Big
stuff
Dipper
up here,
going?
I
What?
can't, your articulation is not clear, or else I need my hearing aids.
Can the
Say it
rest of you
again.
understand me?
Say it again.
Uh, my question was, in a billion years, will there still be a Big Dipper, only it'll be farther to the right or left?
Tim just talked about that. He
Yeah,
said he
it'll
went ahead
be,
500,000 years, and you see the two end stars move differently from the rest.
yeah,
I missed
it
that.
won't
I'm
have the
sorry.
dipper shape.
Right. Yeah.
Got it.
So anyway, this is their associated, they call it members of the moving group. This is the moving group. And then this is stars that are associated with the moving group, but they're farther away. These are stars that have been shed more actively. So they're under the category of stream, which is the phrase that we were introduced to when we discussed globular clusters, because there are streams of stars that are moving together in large linear patterns around an orbit, like dust in a comet's tail that's going to be meteorites when it hits the Earth's orbit. These things are trailing the orbit of the parent cluster. So that's what stream means. And then these are the more of the stream. So they're probably associated with the moving group, but they're much farther away.
Moving group.
Now, they're part of the thing, and I haven't decided if this is going to be in the talk on August 7th or not. Probably not. It's too complicated. But people tried to figure out they're thinking about life on other planets, and it needs to have an atmosphere, and it needs to be about Earth-like, because they wanted to know how big and how small stars can retain an atmosphere. The Earth and Venus have obviously retained atmospheres, even though various different types. But Mars has not really done a good job of that. So they looked at rather an elegant computer program, collecting a lot of other geology programs and astronomy programs. And they looked at as a function of the planet radius, the planet mass, initial internal composition, radiogenetic material abundance. That means radioactive materials, a heat source inside the Earth, like our radioactive nuclear material. Initial carbon content, internal heat flow, degassing rates, atmospheric loss, plate or stagnant lid. We are a planet that has plate tectonics, and when a planet doesn't have plate tectonics, they call it a stagnant lid. And this studies stagnant lid planets, what they did. And then they looked at atmospheric composition, but what they're really after is what is the physics behind atmospheric retention. And it's quite a long, in the talking points, if you wanted to look at that, it's cut down quite a bit, but it still is a long discussion, and we're not going to read that. But these are exoplanet results for the, gosh, I forgot what that is. Does anyone remember what?
You did put it in the talking points. I didn't write it down, but
No, I got it here then.
a little different from
I'm getting
STEM.
there.
In a much simpler level, I got a question on this yesterday, Tom. It was people wanted to know why Mars. I was explaining that it might have had an atmosphere at one time, but the solar winds kind of blew it off. And then they were asking me why, and I wish I had a little
Because it
bit more.
lost its magnetic field.
Yes, essentially that's Chuck's right, got it there.
With its magnetic field?
Yeah.
Yeah.
But doesn't that have to do with the molten core or?
Yes.
Yes. Well, it has to do with the dynamo effect.
Okay.
So you have to have some kind of fluid. So the acronym stands for Smaller Than Earth Habitability Model.
Huh.
So they looked at things between the Earth radius and the Earth mass down to half the Earth radius.
Oh, wow.
And of course, the corresponding from geography or geometry, the corresponding mass, which goes as the cube of the radius. And this goes This is the radius. So, and then this is the gravitational force at the surface, and mantle and surface emission rates. What they got, for example, is summed up in this.
It's really washed out.
Yeah.
Can't see
Okay.
this one, Jerry.
Okay. It's mostly white, so I probably should have left it back up.
Yeah. Yeah, if it turns out to be the same thing, that'll be great.
Well, could I throw in my stupid little question?
Okay.
Can all the elements and even compounds of combinations of elements become gaseous under certain conditions?
Essentially, yes. Some of
Okay.
it becomes plasma.
Okay. Temperature, I think, is a big part of it, right?
It's the only part of it.
Well, amount of the element. There are some elements that are rare, right?
Some are
Not
more
much.
rare than others. Rare earth elements actually is a misnomer. Rare earth elements are not rare, and they're not rare on Earth. It's just that they're difficult to find and they're difficult to refine. So China has invested a lot of money in refining it, and they've become the source. And several organizations that produce rare earth elements here in the US, they shut down because they couldn't compete economically with China. So they're struggling to get back up online again now that rare earths have become popular for
Is China really getting most of that from Africa?
no, they're digging up rare earth elements are everywhere.
Okay.
Yeah,
So
we got
there's
them in
some,
Death Valley somewhere. They're digging here.
I
That's
think one of the
lithium,
biggest
I think.
deposits is somewhere around New Mexico.
There's
But-
big deposits under the Appalachian Mountains too. So
Yeah. Yeah.
in addition
Well,
to digging it down for coal, they can dig it down for rare earth elements.
Wouldn't it be fair to say, Jerry, that there's far less radon and xenon and neon and than carbon and oxygen?
Those are inert elements, not rare earth elements.
Yeah.
Okay, but they're rare. There's less of them made, aren't they?
Those are rare because you don't find them in minerals. They're not chemically active. They don't bind to other things. They're just gas. And for example, the most important gas for us is helium. And helium we get as a byproduct from methane wells, natural gas wells.
Is that where we get helium? Because I've heard over the years we're running out of it.
We are. When I was
Really?
in grad school in the 70s, liquid helium was roughly equivalent to a bottle of Napoleon brandy in cost.
Well, if we could figure out a way to do cool fusion, would make helium, wouldn't we?
Yep.
Yeah, we recompressed helium at Arizona in
Yeah.
our labs.
Is that right?
We recycled the gas, and then we had another refrigeration unit basically that dropped it down low enough that it liquefied.
Yeah, 4.3 Kelvin.
And there's a large deposit of it that's been found someplace like Minnesota in related to a rock formation that kind of traps it as it comes bubbling up from the interior.
But other than the fact that it makes us sound like Mickey Mouse, it's harmless to breathe, isn't it?
Well, it's like water. You can drown in it.
Yeah.
I was bringing a soccer team home in my van from a soccer meet out of town, and they had a balloon of helium with them in the back. And all of a sudden, I heard that one of the girls in back had passed out,
Yeah.
slammed on the brakes and pulled over. And the rest of the team said, "Oh, she does that all the time."
Yeah.
So I said, "Well, she's not doing it in my van," and I took the balloon away.
Yeah.
Yeah.
She just had breathed too much of it.
Yeah.
So anyway, this is the chart. Can you see this?
Yeah. And amazingly, it was washed out too much.
It's just white with some few dark lines on it. This is atmospheric pressure of CO2. For that study, they assumed any atmosphere the atmosphere they studied is a CO2 atmosphere.
Yeah.
So this is what their model predicts for the retentability of CO2 atmospheres on Earth, Venus, and Mars.
Right.
This is Earth, and you see that it's going out here time in gigayears.
Oh, I thought it was ginormous. Sorry.
Ginormous, yeah.
Ginormous.
Ginormous years.
Yeah.
And then here's for Venus. Venus will also retain its not too useful thing, and it does for tens of billions of years.
Mhm.
Mars will lose its atmosphere after, this is 1 billion years, half a billion years, about 0.2 billion years. So after about 200 million years, its atmosphere is gone. And that's just what we're seeing right now. And
It's interesting that the atmospheric pressure of CO2 on Venus is showing as less than on the Earth.
yeah. Well, that's their model. Doesn't get
Yeah.
everything to 4 decimal places. So this is in bars. The Earth is 1 bar. This is 10 to the 2. This is 100 bars. So this is an accurate number for Venus.
Yeah.
But you wonder where Earth's went.
Yeah.
Right. And that axis,
Earth should be here.
yeah, that axis is logarithmic, the y-axis.
Yes, yes.
Slowly catching up with Venus, aren't we?
Yeah.
Okay.
Wow. Got a side question real quick.
Yeah.
Billions of years ago, supposedly Mars had a bigger atmosphere, and they're saying it was almost Earth-like. It had water. Still, it was
That's the conjecture.
okay, but it was still back then where it is now, so I'm sure it was colder still, right? Still had to be
No, the
cold.
carbon dioxide lets you get warmer.
Yeah.
Oh,
The greenhouse gas. That's
So
why
it
we're
had a
having
little
trouble
bit-
with it.
had a little bit of Venus going for it, but that would have been okay for life if they find any.
Venus has always been too hot, in my view.
But we're
Anyway,
in the middle of the Goldilocks zone, aren't we? Are those other 2 planets in the Goldilocks zone?
They're
Venus?
on the edges.
They're on the edges. Mercury, that's for sure.
Yeah. And
Yeah.
of course, Goldilocks zone is defined by what we've evolved to live into. So
yeah.
Was I correct yesterday in telling a person that Venus was the hottest planet in the solar system? And he said hotter than Mercury. Now, I didn't think about the near side.
No, it is hotter than Mercury, but it's not as hot as, for example, Jupiter or Saturn down inside.
I
Down
thought it was
inside.
hotter than all of them.
On the surface, yes.
Yeah, on the surface, yes. Anyway, this is the range of of masses that they looked at from Earth, which is this top line up here, and there it is at 100 bars again. And then they went down to half a bar here, or half of the Earth radius. Mars is smaller than this, but half an Earth radius is like this. This one, let's see, 1, 2, 3, 4, 1, 2, 3, 4. So about 7/10 of an Earth, between 7/10 of an Earth and 0.8 of an Earth, you lose the ability to retain an atmosphere. So for looking at exoplanets that are potential atmosphere retainers, we need to look at things that are about 80% of Earth and above, but not too far above, because when you get up to super Earths like Neptune and Uranus, they retain too much atmosphere. There's no real surface on them. So we're in this region here that really cuts into, we're getting a fairly accurate view of one of the components, one of the factors of the Drake equation.
Oh.
So how common are these planets? We know how common exoplanets are based on their mass, because we have plots now of, I don't think I've included one though. No. What is this? Oh, that's the next topic. But anyway, our galaxy is made up mostly of red dwarfs, like TRAPPIST systems. Those planets are all too small to retain an atmosphere. And that's what we're seeing from them, is the atmospheres are not there. They are, and they are also at a star which is very active, a lot of flares, a lot of mass eruptions. So those things aid in sweeping away an atmosphere on a planet. So it narrows down our search for what we need for life-giving or life-sustaining planets. This is
Juno.
the asteroid Juno. Oh, 15 is not the name of the asteroid. 15 is the number of slides from the beginning. This is 3 Juno. Yeah, they're up at 3 Juno. And there it is in the evening sky at 9 o'clock, arising in the east, along with Pluto. So it's a good object. It's right about 9th magnitude here. It's about 9.2 magnitude. You will not see it with your naked eye, no matter how good your eyes and how recently you had your cataracts removed. So you need a telescope or binoculars to see it.
And a bright moon.
Yeah.
You have a bright moon, yes. But the good thing about the bright moon right now, because we're very near the full buck moon, I think it is it's real low in the sky. So it's almost on the horizon of my house. I can see it out my bathroom window. So
Is Juno going to occult the moon, or well, it wouldn't occult it, but it will go behind it.
No.
No, it's not. It's just in the vicinity. Got it.
these are captured frames
Wow.
at different wavelengths. 500 nanometers, that's right in the green part of the spectrum. 700 is just to the right of the hydrogen alpha, which I think is 660 nanometers. And then here we're out in the almost to a micron. So we're looking out here. So these could have all been taken with our regular silicon-based CCD or CMOS cameras. This is out near 1 micron in the near IR, and this is getting very close to the cutoff for silicon. So these are different, what it looks like, and it's rotating between these different pictures. So don't look for the same feature and line them up in your mind. It's not going to get there.
Is it as big as that one you portrayed earlier?
It's bigger.
Bigger than the one behind the city skyline that we saw?
Yeah, this thing's 100 and something miles across.
Oh, Jesus, I guess so.
So this is one of the most accurate pictures we have. This is Juno taken by ALMA, the giant radio telescope in South America.
Wow.
And this is a still frame from a video. This is a processed frame from those video, but there's a lot of imagination in this. This is a processed image. It's not an actual image taken of the thing. We haven't got anything to fly by it yet.
It has a little gravity if it's that big.
Yeah. So this is
It's track.
Oh yeah, this is where Juno is as of today. This is where Mars is. So the whole time it's way out beyond Mars. It's in what we recognize as the asteroid belt. It's tipped more from the ecliptic plane. Here it's below the ecliptic plane. Here it's above the ecliptic plane. So it's tilted more than the one we saw earlier. The Mercury, Venus, Earth, Mars, and this thing out here is Jupiter.
And it used to be a planet.
It was registered as a planet one time.
Really?
But you know what? These objects don't care what we think of them.
Yeah. And that's why minor planet is a better term than asteroid.
Yeah.
It's not a dwarf?
No. And I heard a better term for dwarf planet, and that was remote planet.
Remote planet?
Yeah, at least for the ones in the Kuiper Belt and Trans-Neptunian.
Yeah. But
because
it series then is an unsolved problem.
Yeah. But it does give you could still consider Ceres a minor planet. And that gives a much better sort of indication of the fuzziness, because they're all planets, you know.
Yeah.
Well, isn't there a limit of diameter? Ceres, for example, is the dwarf, isn't it?
Yes, but that's according to that Mickey Mouse definition that they came up with.
which would involve a diameter. Is it 300 miles or
Well,
larger?
no, it depends on what you're made out of. It's a hydrostatic equilibrium thing.
It's the
Okay.
fact is Ceres has pulled itself into a sphere, roughly.
Yeah,
So,
this
and
one didn't appear to be a sphere at all.
no,
Right.
this is more of a Vesta type.
Potato.
If you were to land on it, there'd be some giant mountains, wouldn't there?
Well,
Yes, there is. Comets, you get giant mountains. There's a famous picture taken from the surface of a comet showing what looks like a valley and then a steep cliff with, all sorts of crap flying around, snowstorms.
that was, Churyumov
Yes,
Gerasimenko.
that one.
But this is an interesting way to show the angle above the ecliptic, the lines going down. I've never seen that before. For
Yeah.
Yeah, it's
example,
really neat.
you could definitely demonstrate Pluto's orbit, and I don't think I've ever seen it done that way. I've seen it angled, but never with those little ratchet comb filters or whatever you call them.
Well, go to this website there at the
It'll have that.
JPL Dynamics. Yeah.
But Juno doesn't have any stuff to make a tail, so it's not a comet.
At least not currently.
Okay, am I still here? You can see me?
Yep.
Yeah,
Yeah, Jerry.
Good.
welcome us all back. Are we done?
No, you're
Oh,
not.
no, there's
I
9 more
just
minutes.
locked myself out and I got a better way of getting back in.
Really?
Okay. So who made up the constellations?
Aha.
The IAU.
Yeah.
The ancients. Wasn't the ancients?
Well, there were up until, what is it, 19, I have it in the talking point.
1930.
Yeah, the star charts, if you have one from that old, from 1800s and stuff, you see a lot of non-straight lines defining the constellation boundaries. And they argue with each other. Different atlases have different definitions of the constellation. The IAU in 1926 or something, or 1930?
They finally promulgated it in 1930. I don't know when they started.
Yeah, but they finally finished one in the 1930s. And what they did is embodied in this particular one, the constellation of Andromeda. And what they did was all boundaries are either segments of declination, or this is right ascension or declination. All of them straight lines with 90-degree curves to them now. And then the specific boundaries were defined. They were trying to get away from having a single star in one constellation and someone else said it should be in the other. So they just decided on it. Things made by committee are never perfect. There are still things that are listed for alpha for one constellation, but they're actually in another constellation. So, but we kind of turn a blind eye toward that. So this defined
And
the
that's
shape.
happening right there in Andromeda with Alpha being part of the Great Square of Pegasus usually.
Yeah, right here.
Yeah.
Oh.
So, and they defined for the first time the 88 constellations. They broke up a big one, Argo Navis, which was a big ship, and they adopted a lot of the ancient Greek definitions of the constellations and gave us what we have today.
Well,
So
was
now they're
Argo,
working on planetary definitions.
this Argo Narvis, did it portray something? Was
It was
an
a ship.
animal?
Is Jason's ship?
A ship?
Jason and the Argonauts. It was his
Right.
ship. Yes.
Yeah.
And it broke up and became what? 2 or 3 other
Oh, it's a
constellations
bunch. The sails, the compass, the keel,
And
Yeah.
that are still up there? That's what we,
the poop deck. Yeah, it's
all
still
the
up there.
stars are still up there.
Yeah.
I thought mostly all of them were animals.
Nope. That's the
Maybe a couple
Zodiac.
couple
Zodiac
of
comes from zoo.
Right.
Got it.
So it really should be Zodiac.
Yeah.
And Tim, do you see 404?
Yes.
Yeah, Ghost of Meroc.
Yeah.
Yes.
891's like a needle galaxy. It's very, very easy to find.
Yeah.
Mhm.
That's a really nice one. You'd kind of
891's really pretty.
yeah.
And of course, there's the Andromeda complex there. I saw all that.
Anyway, we are going to have the July 31st, 1 a.m. We're going to have the Capricornus the Aquariids
Yeah.
meteor shower coming right next to the full moon. So
Yeah.
you're gonna see nada.
Yeah. And Ron, you see the name of that star there near the moon? Dana Baljetti?
Yeah, what does that mean?
Means the goat's tail.
Well, it certainly looks like one, doesn't it?
Deneb means tail. So you got
Tail, right.
Tabula for the tail of the lion. You got Deneb for the tail of Cygnus the
Right.
swan.
And
And-
Denebola.
And the Aljetti refers to a goat,
Okay, what does Fomalhaut mean?
Mouth of the fish.
mouth of fish.
Okay.
I still call it Fomalhaut. My brother Paul taught me Fomalhaut, so it stuck.
Well,
We taught ourselves Fomalhaut too, but then this radio
your-
show from
Your
the-
radio program came on.
yeah, they pronounce it Fomalo, and so I've sort of adopted that without thinking about it.
Okay.
You'll also see Formalhaut.
Mhm.
well, is it possible, gentlemen, to explain to me what radiant means? There was a dot there, or a circle. Go back to
That's
that.
where they
location.
radiate from.
Yeah, it's the location, Ron, if you were to trace back all of those meteor lines there, that's where they appear to come from. That's the
Well-
radiant.
It's an imaginary point.
That's right.
Okay, but that's part of the track of the former comet that left it. Was it coming from us, or toward that, or by that, or I don't
Doesn't
know.
matter. Doesn't matter. It left stuff behind and we plow through it.
Mhm.
If it's in an orbit that's retrograde, then we see really fast meteors, and if it's in an orbit that's the same as ours, then we see slower meteors.
Yeah.
So all those radiants for the different meteor showers are different spots in the sky that never change,
They drift a little bit.
Yeah.
but we pass through them. How do we know we're passing through it?
Because we
get
see
a
a
meteor
meteor
shower.
shower.
So which shower is this, Jerry?
This is the Delta Aquarids. These are pieces
Delta
of Halley's
Aquarids.
Comet.
Got it. Got it.
But
Okay.
there's also the Capricornids, I
There are
think.
two of them at the same time.
Yeah.
Wow.
And you were telling me that the best time to view these is after midnight because then it's hitting us head
And
on.
Yeah.
you're looking out of the windshield of the Earth in its orbit,
Yeah.
like a
That's
car
interesting.
driving through a rainstorm. The rain hits on your windshield, it doesn't hit on your back window.
Yeah.
More
this
bugs
one-
on your windshield.
This one is the Southern Delta Aquariid meteor shower.
Okay.
It's just very difficult for me to understand why all the meteors seem to come from that dot. Why not just everywhere if we're going through the.
They appear
Right.
anywhere in the sky, but if you trace their paths back, it comes from where the comet left the debris.
Yeah. In about 2 weeks after this, Ron, you get the Perseids.
Yeah.
Yeah,
In
I
2
know.
weeks, the moon will be really teeny weeny.
Yeah, it'll
Yeah,
be
it's going to
much
be a
better
good
display.
Perseids this year.
Yeah.
So there's a spot for Perseus, and we know where it is, but we're not there yet.
Right.
Mhm.
Although we're starting to get pieces of it already because it's such a big tube of debris.
Yeah.
Jim, tell me you don't understand this either, please.
I'm getting there though. You know, we were up at Refugio and somebody mentioned, one of the campers mentioned that the night before they really saw a bright object
Mhm,
going
mhm.
through the sky, or maybe it was even when they were looking through binoculars or something.
Mhm.
And I said, well, it might have been just one of the satellites. And she said, well, it was reddish. And I said, well, that was probably a meteor.
Yeah.
So
What they call an errant, Tim, an errant.
yeah,
You know,
and
for
I
one
think
of these
Ronnie
shows.
was kind of, saying that is that you can at any time you can see these all over the
For
sky,
sure.
and
Right.
that's what I'm getting. But this thing of the radiant is where in our orbit where we're crossing the path where that comet was,
Yeah.
or you know, and we're getting the debris from that tail
Yeah.
Yeah.
that
Mhm.
we're passing through. And so I think that's where that radiant is, Ronnie, when we're kind of like seeing it coming from this one point. And
Yeah.
I imagine, and maybe I'm wrong about this, you guys, is that if we're viewing this after midnight, it's like bugs on the windshield. But
Yeah.
as we go through this, will it appear to be in a different area of the sky or the same area?
Well, of course,
Well,
the Earth will rotate and that radiant will move with it.
Yes.
Okay,
It'll
okay.
stay in the same spot as far as the constellation.
As far as the constellation, okay.
Yeah,
So the
Tim, I was going to say, Tim, many years ago, I was camping in Canyonlands in southern Utah, and it was during the Perseids, and one of these things produced a bolide. It was a big boom, and it was just
Oh,
amazing experience.
oh,
I've only
oh.
seen a couple of those, and it usually happens in very dark sky.
Yeah.
We were at the museum one night, and uh, something I think it was up to the north, and I'd never seen colors in a meteor like that. It was just
See green?
intense.
Did you see green, Tim?
Green, and I think it was
Yeah.
oranges. I think orangish, but there was a couple of different colors, and
Yeah,
I'd never seen that. And I asked, somebody. I said, "Wow, did you see that?" And Chuck chimed in and he said, "If you had to say that, they didn't."
Yeah.
Yeah.
And the colors are telling you what elements are fluorescing there. So the
Right.
green, I think, is nickel,
Yeah.
Okay.
and you get purples from other elements. And
What would the orange or the reddish? What would that be?
you'd have to look it up. That might actually just be nitrogen or something in the Earth's atmosphere fluorescing.
It was so large that I thought it might have been atmospheric, and the other one would have been the comet itself,
Well-
or the meteor itself.
Well, it's always atmospheric. The brightness that you see is the ram heated air.
Okay,
The colors you see are when that causes some of the elements to ablate off of the meteoroid.
so that's elements that you're seeing that's atmospheric. I'm getting there.
Yeah, the light part is all atmospheric.
So, Ronnie, the short answer is no and yes.
Yeah.
Anything that makes a meteorite has got to be big enough to inflame by hitting the atmosphere. It can't be just an atom or a molecule off that
It can be
comet. It
pretty
has to get
small, like dust or grain of
Yeah,
sand.
yeah,
No.
I've heard it's really small.
And
Yeah.
just being hit by the sun makes those little pieces leave the damn thing, burn off.
Like I've heard
Well-
that a piece of gravel would be rather large.
Yeah.
Yeah, these are about the size of a grain of sand is what you normally see as these little white sudden
Wow,
streaks that are so quick.
wow.
The entire orbit that the comet
It's littered.
traced out in the sky, in the solar system,
It's
that is
littered with those.
populated with debris from the comet. You can
Wow.
go through that orbit at any point around it and you will get a meteor shower.
And how many of them do we go through?
Lots.
Yeah.
Every
And
week.
we go through
Halley's.
we go through the train from Halley's Comet twice a year. So the Delta Quaerids, that is the one now, is when we go through one part of the orbit, and then the Orionids in October is when we go through the other part of the orbit of Halley's Comet.
Oh, wow. Oh, I see. Okay,
What
I'm
what
getting
a
there,
mess.
Ronnie.
what a mess. We need a large vacuuming of our solar system, let me tell you. Hey, that does it. We're going to convene again here on the screen again next week, gentlemen. If you'll do it, I'll do it. SBAU Astro Hour number 284 next week. And don't forget, 2 weeks away, Friday the 7th, the president's speech, the search for habitable planets. We're going to have questions. The next night, incidentally, is second Saturday Star Party.
Mhm.
And so we thank you on behalf of the club, Santa Barbara Astronomical Unit. See you next week.